So for number 2, they want us to outline a direct proof of this theorem that says if A and B are invertible matrices, then the product AB is invertible. So they want a direct proof of the theorem and then a direct proof of the converse of the theorem. So the theorem is of the form if P, then Q. So that is the theorem where P is going to be if A and B are invertible matrices. So that's our hypothesis. And our conclusion Q is the product AB is invertible. So that's the theorem. This is the theorem. And then the converse is going to be if Q, then P. So it's going to be if the conclusion, then the hypothesis. And so this is going to be the converse. So let's do that. So for item A, we want to outline a direct proof. So a direct proof begins by assuming the hypothesis. So we're going to go assume that A and B are invertible matrices. So we have assumed our hypothesis, and then we would develop our proof, and then we would show the conclusion. So we would say, then product AB is invertible. And so we would say, therefore, if A and B are invertible matrices, then product AB is invertible. Okay, so that was for item A. And for item B, let's write that down. So for item B, we're going to now do a direct proof of the converse of the theorem. So we're going to begin by assuming the hypothesis, assuming the conclusion. So we're going to go assume that product AB of matrices A and B is, I guess I should put a comma here, is invertible. So we begin by assuming our conclusion, right, that the product AB is invertible, and then we would develop this, and then we would say then the hypothesis. So we'd say then A and B are invertible matrices. And so it would say, therefore, if product AB is invertible, then matrices A and B are invertible. Okay, so we've done a direct proof both of the theorem and of the converse of the theorem. So the theorem, we just assume P and show Q, and the converse, we assume Q and show P. Now, we haven't done the proof, we've just done an outline, and that is it for number 2.